So guys, here initiate one more time we came on the DSA, and in the one video we are covering 3 to 4 topics, but this one 10 minutes video has been came, and this one 10 minutes video on the DSA in which we cover two or one topic. Okay, and first topic name is quick shot. Okay, first we cover about the quick shot, what is quick shot and all the think of it. Okay, then we cover one more topics, okay, one more many type of topics. Okay, so get ready for it. So now let's move to our computer screen and let's do a coding with loving it. Guys, in today's video of DSA, we are covering our new more topic by the name of quick shot. So I know many people do not know what is the quick shot in the DSA, so let me explain you because I came here for you. Okay, so quick sort is a one sorting algorithm. So it is based on divide and conquer that picks an element as a pivot and partitions the given array around the picked pivot by placing the pivot in its correct position in the sorted array. Table of content. First table of content is how does quicksort algorithm work. In today's video we are learning about it, and we are working of partition algorithm with illustration. Then we are illustration of quicksort algorithm, and then we define a complexity analysis of quicksort, then advantages of quicksort, disadvantages of quicksort, application of quicksort. These all things we are covering in today's video, so get ready for it. So now let's start without wasting any time. First of all, we learn about how does quicksort algorithm work. Quicksort works on the principle of divide and conquer. So I know many people do not know what is a divide and conquer. So if you want to know this, so come on to here and search here what is divide and conquer. So there the Google has been tell you divide and conquer is a problem solving strategy. Okay, this is one problem solving strategy. Now principle of divide and conquer, breaking down the problem into smaller sub problems. There are mainly 3 steps in the algorithm. First, choose a pivot. Select an element. Select any element from the array as the pivot. The choice of the pivot can vary. For example, first element, last element, random element, or median. Number 2, partition of the array. Partition the array. Rearrange the array around the pivot. After the partitioning, all elements smaller than the pivot will be on its left, and all elements greater than the pivot will be on its right. Okay, the pivot is then in its correct position, and we obtain the index of pivot. Number 3, recursively call. Recursively apply the same process to the 2 partitioned subarrays left and right of the pivot. Now number 4, base case. It is the recursion stops when there is only one element left in the subarray as a single element is already sorted. Here's one basic overview of how the quicksort algorithm works. Choice of pivot. Now choice of pivot, so if I give to the choice of pivot, so let me click on it. Okay, there are many different choices for picking pivots. Always pick the first or last element as a pivot. The below implementation picks the last element as a pivot. The problem with this approach as it ends up in the worst case, the array is already sorted. Now one more, pick a random pivot. Okay, means pick a random element as a pivot. This is a preferred approach because it does not have a pattern for which the worst case happens. Pick the median elements is the pivot. This is an ideal approach in the terms of time complexity, as we can find median in linear time, and the partition function will always divide the input array into 2 halves, but it takes more time on average as median finding has high constants. Partition algorithm. The key process in quicksort is a partition. There are 3 common algorithms to partition. All these algorithms have 0 and time complexity. First, naive partition. Here we create copy of the array. First, put all smaller elements and then all greater. Finally, we copy the temporary array back to the original array. This requires O and extra space. Number 2, Number 2 is limiter partition. Okay, so what is that? So let me tell you what is a limiter partition. We have used this partition in this article. This is a simple algorithm. We keep track of the index of smaller elements, okay, and keep swapping. We have used it here in this article because of its simplicity. Now, one more is Hori partition. This is the one fastest of all. Here we traverse array from both sides and keep swapping greater element on the left with smaller on right. While the array is not partitioned, please refer Hori versus Lemata for details. Working of partition algorithm with illustration. The logic is simple. We start from the leftmost element and keep track of the index of smaller or equal swap element Si. While traversing, if we find a smaller element or swap the current element with ARR, otherwise we ignore the current element. Okay. Let's just understand the working of partition algorithm with the help of the following example. Illustration of quicksort algorithm. In the previous step, we look at the how partitioning process rearranges the array which is based on the chosen pivot. Next, we apply the same method recursively to the smaller subarrays on the left and right of the pivot. Each time we select new pivots and partition the arrays again. This process continues until only one element is left, which is always sorted. Once every element is in its correct position, the entire array is sorted. Below is one image illustrates how the recursive method calls for the smaller subarrays on the left and right of the pivot. Quicksort is a critical algorithm in the industry, but there are other sorting algorithms that may be more optimal in different cases. There is one code in C++. So let's run it. So it gives you the output sorted array 1, 5, 7, 8, 9, 10. And why? Because of it gives you this type of output. Because of why? Because like I have told you, it gives you this type of output. It is sorting the array of our. Okay, now let me remove the number. Remove the numbers 1 till 53. So now it is starting to remove it. When it will remove it, so we will be run this code in our code editor. So it has been removed all the numbers. So let's copy it and let me paste it. So when I run it, so it is giving me, so it take a little bit time. Then I write the my arrays 10, 7, 8, 9, 1, 5. But it is giving me 1, 5, 7, 8, 9, 10 because it has been sorted the array. In the previous videos, I have already told you how to sort the array. Complexity analysis of quicksort. Time complexity. Best case is n log n occurs when the pivot element divides the array into two equal halves. This is a best case. Average case is O n log n. It is on average the pivot divides the array into two parts but not necessarily equal. Now the worst case is 0 and 2. It occurs when the smallest or largest element is always chosen as a pivot, for example sorted arrays. Auxiliary space 0n due to recursive call stack. Please refer time and space complexity analysis of a quicksort for more details. Advantages of quicksort. It is a divide and conquer algorithm that makes it easier to solve problems. It is efficient on large data sets. It has a low overhead as it only requires a small amount of a memory to function. It is cache friendly as we work on the same array to sort and do not copy data to an auxiliary array. Fastest general purpose algorithm for large data when stability is not required. It is tall recursive and hence all the tail call optimization can be done. Disadvantages of quicksort. It is a worst case time complexity of O and 2 which occurs when the pivot is chosen purely. It is good choice for small data sets. It is not a stable sort, meaning that if two elements have the same key, their relative order will not be preserved in the sorted output. In case of quicksort, because here we are swapping elements according to the pivot's position without considering their original position. Now, application of quicksort. I told you about the advantages and disadvantages. So now let me explain you the application of quicksort. It is efficient for sorting large dataset with a O log n average case time complexity we use in partitioning problems like finding the kth smallest element or dividing arrays by pivot. Integral to randomized algorithm offering better performance than the deterministic approaches. Now, we applied to in cryptography for generating random permutations and unpredictable encryption keys. Then we partition can be parallelized for improved performance in multi-core or disputed system. Okay. Now, important in the theoretical computer science for analyzing average case complexity and developing new techniques. Please refer application of QuickShot for more details. So our this chapter has been ended. So we start in the next video. We talk about sort an array in a waveform. So our this chapter has been ended by the name of QuickShot. So our this video has been ended in that of the DSA about the QuickShot. So I hope you enjoy this video. So if you enjoy, so please like this video, share and subscribe to my channel, and don't forget to all the notification bell also. So you never miss about these type of videos on the data structure and algorithm. And I know I uploaded a 30 minutes video, then I come on to the 10 minutes. So sorry for it, but I do my best to upload a 30 minutes video. I do my best. Okay. So but first of all, you show me your support, then I upload a many big videos. Please support me. Okay. So now let me meet you in the next class and next very amazing like that type of videos. But let me give the outro of this video in the big screen. So let's move toward onto the big screen, and now let's give the outro of this very beautiful video. And now let's give the outro of this video. And there you have it, folks. Algorithms aren't so scary after all. Just a little logic, some patience, and maybe a snack break along the way. Remember, every complex algorithm was once just a simple idea. If you enjoyed this video, don't forget to like, share and subscribe, and hey, hit that notification bell. It's the closest thing to an algorithm that guarantees you will never miss out on my videos. Until next time, keep coding, keep laughing, and remember, debugging is just like solving a murder mystery. But you are the murderer. So see ya.